This lesson is about density and design problems. All right, problem number one is about population density. And we know that population density is all about the population divided by the area. Okay, and that will give you the population density. All right, didn't leave myself a lot of room there, but you get it. So population divided by area. Keep that in your head. Okay, so let's calculate the population density for each state. So for state A, okay, the population density is the population divided by the area. So if I do this population divided by this area, that's going to give me the population density. So I shall take my handy dandy calculator and handle that. Okay, so I'm talking about $1 million. $1 million. Y'all probably have no idea what I'm talking about. And then 173. Ask your parents. Anyway, divided by 2,677. Okay, so we get ourselves a population density of 394.16. Or, I'll just round to a whole number. So 394. Okay, 394 people per square kilometer. All right, so let's do that for all of the states. Now let's find the population density for state B in the same way. We'll do the population divided by the area. Okay, I'm getting 37. Yeah, I'm rounding to the whole number, so I'm getting 37 people per square kilometer in state B. That's a big difference. All right, let's go for state C. Population divided by area. I'm going to do these last two off camera because I think you get the idea. You don't need to see me typing. All right, so there we have the population density of each of these four states. Now, which statement regarding these four states is true? The state with the lowest population has the greatest population density. Let's see. The state with the lowest population is the first one. And it does not have the greatest population density, so that's false. Okay, the state with the second lowest population has the lowest population density. Okay, state B has the second lowest population, and it does have the lowest population density, so that is true. Okay, the state with the lowest population has the lowest population density. Nope. The state A has the lowest population, but not the lowest population density, so that's not true. The state with the second greatest population has the lowest population density. No. Second greatest population, lowest population density? No, that's not true. All right, so it looks like only the second statement is true. Let's see how we did. Yep. High population density can cause increases in competition for resources such as food and shelter. The table shows the number of zebras living in 4 different regions. In which region is competition for resources most likely to be the greatest? Okay, so if the competition is the greatest, that means we're looking for the highest population density. Okay, all right, because that's where the competition is going to be the tightest, where the population is the most dense. Okay, so let's calculate the population density for each region. Okay, and it'll be just like we did on the last problem. We'll do population divided by the area, and that will give us the population density. Okay, I'm only going to do one of these on camera, and just to make sure you have the idea of what I'm doing. So I'm doing 1,312 divided by 212. Okay, so that is how much should I'm just going to round to a whole number for this. So 6. Alright, then I'm going to do the same thing for the rest off camera. So these are the population densities for each region. We are looking for the highest population density for the most competition, and that is region C. Let's see how we did. Oh, yep, we're good. We're real good. The population density of Peru 1 year was approximately 23 people per square kilometer. Brazil has a land area of approximately 8.5 million square kilometers. If Brazil had the same population density as Peru that year, approximately how many people were living in Brazil? Okay, well, we know that population density, which I will call D, should equal the population, all right, divided by the area. Okay, so if Brazil has the same population density, that means the population density has to be 23 people per square kilometer. All right, so basically we know that the population density has to be 23. So far that means we have 23 equals. All right, we also know that Brazil has a land area of approximately 8.5 million square kilometers. Okay, so I'm going to put 8.5 million, all right, we just know it's in millions, down here for the area. And we're supposed to be finding how many people were living in Brazil. So we're looking for the population, which I will just call P. So it's just a matter of solving this formula and just not forgetting that we're talking about millions. So all I have to do is multiply both sides by 8.5. All right, and that should get population by itself. So 8.5 times 23 okay, is 195.5. Okay, now this is 195.5 million. Okay, and that's the same thing. If I want millions, this would be the same thing as 195,500,000. If I just go ahead and write it in millions. So either one of these I will be looking for when I do the reveal. So let's see how we did. Okay, 195,500,000. Well, I seem to have lost a zero here. But yeah, this is the correct answer. We nailed it. Crop yield is the ratio of the number of bushels harvested to the number of acres used. Let's write that down. All right, crop yield is equal to the ratio of the number of bushels harvested to the number of acres used. Okay, can I simplify this formula a little bit? Let's see. Crop yield, let's call that Y, is equal to the number of bushels divided by the number of acres. Y equals B over A. Okay? Now what? This year, a large farm harvested rice from 690 acres. Okay, so it sounds like we know that this is 690. Now, the crop yield was 7,553 bushels per acre. Okay, they're telling us the yield. All right, that means they're giving us this number right here is 7,553. Ding. Okay, approximately how many bushels of rice were harvested? So it sounds like we are being asked to find the number of bushels of rice, which I could call it X, or I could just leave it B to remind me that it's bushels. So I'm just going to leave it B. Okay, so substituting in the numbers that I have, that tells me that I've got 7,553 is equal to the number of bushels divided by 690. So to solve this equation for the number of bushels, you multiply by whatever's in the denominator. So I'm going to multiply both sides by 690, yeah? Yeah. That way these are going to cancel out, leaving bushels all alone. So whatever this is, 690 times 7,553. Wow, I did not get a chance to write that down. So let's see, what do I have here? 5,212,570. Oh, yeah, I missed that a little bit. 211,000. Okay, that should be it. Reveal. Okay, they went ahead and set it in terms of millions of bushels. All right, so 5,211,000. You can see that's the same thing as 5.2 million. You know, we're rounding. So we're good. We're still good. Okay, here we are again. Crop yield is the ratio of the number of bushels harvested to the number of acres used for the harvest. Yeah, so we just talked about that. So again, I will write that as a formula. Crop yield is equal to the number of bushels harvested divided by the number of acres. All right, yield, bushels, acres. This year, the harvest at a farm was 94,010 bushels. Okay, all right, so we got the bushels, man. So we're told that this number is 94,010. Resulting in a crop yield of 170 bushels per acre. So we're told the yield is 170. Alright, so substituting those values in, that gives us 170 is equal to 94,010 divided by the number of acres. To the nearest whole acre, how many acres were harvested? So we're being asked to solve for this. Now let me just mention the shortcut, and then I'll go ahead and do it the long way. But a long time ago, I noticed that this happens often enough, it was worth memorizing that if anytime you have a variable that's in the denominator like this, you can switch the denominator with this number that's out here by itself. You can reverse these and get a valid equation. So if I put the a out here and the 170 down here, that would give me a is equal to 94,010 divided by 170. Okay, I've been using that for years, decades. So it's second nature to me now. So anytime I see a variable in the denominator and then set equal to a number, I just swap those. Okay, and then of course I can just put that in my calculator to get the answer. Now, you know, so if I want to do this without doing like little tricks, which I generally frown on little tricks, but for some reason I dig that one. In general, what you want to do is multiply by whatever is in the denominator. So if I multiply both sides by a, okay, if I multiply both sides by a, then these a's would cancel out. And then that would give me 170a is equal to 94,010. And then to get a by itself, I would then divide by 170 on both sides. Okay, so the 170s would cancel out, and then that would give me a is equal to 94,010 divided by 170. Okay, so notice that's the same thing I got when I said, let's just switch these. Okay, same thing. So it's just quicker if you know the shortcut, but you know, no big deal. At any rate, you have to go ahead and do the calculation. So 94,010 divided by 170. 553. Okay, so 553 acres. Let's do the reveal. Kabam! Oh, yes. Okay, a company needs to package 2,400 pencils. A box in the shape of a rectangular prism can hold 60 pencils. A cylindrical container can hold 80 pencils. Each box costs the company 50 cents, while each cylindrical container costs 75 cents. Which packaging should the company use to minimize the cost? Okay, so let's take some notes. So a rectangular box, you know, the prism thing, can hold 60 pencils. Okay, should I try to draw it in 3D because it's a box? Yeah, you guys will forgive me for my lack of drawing skills. Whoa, and it disappeared in protest of being drawn. Okay, and then the cylindrical ones, so that's like shabam. Okay, they can hold 80. Alright, that's just some notes. Okay, the box costs 50 cents. How do I want to do this? while the cylinder costs 75 cents. Okay, either way, we need to make 2,400 pencils. All right, that's the total. So let's keep that in mind. All right, total 2,400 pencils. Okay, so if we went with the box, okay, so let's talk about the box first. Say if we did the box. Okay, let's see. How many boxes would we need to hold 2,400 pencils? How many boxes would we need? Well, if each box holds 60, let's see how many times 60 goes into 2,400. So, okay, so how many boxes needed? All right, to figure that out, we would do 2,400 divided by 60. All right, however many times 60 goes into 2,400, that's how many boxes we're going to need. So if you do that calculation, 2,400 divided by 60, we would need 40 boxes. Okay, so let's see, how much would that cost? Well, each box costs 50 cents, so the cost would be 40 times 50 cents. Okay, so let's do that. So if we did 40 times 50 cents, that's $20. Okay, so the box method would cost us $20. So now let's do our calculations again, but this time let's do it with the cylinder and see how that turns out. Okay, so cylinder. Okay, so again, let's see how many cylinders would we need? Okay, and again, we would take the total number of pencils we need to hold, 2,400, and I'm going to divide that by 80 this time. All right, because however many times 80 goes into this number, that's how many cylinders it would take. All right, so what do you want to bet? It's going to be 30, right? Because 24 divided by 8 is 3. Okay, we've got to work on our mental math sometimes. Okay, so of course that does turn out to be 30. All right, so we'd need 30 cylinders to get it done. So what about the cost? Well, if we take our 30 cylinders, each one is 75 cents. So 30 times 75 cents. That should tell us the cost. $22.50. Okay, so we should go with the box because that's going to be $2.50 cheaper. All right, let's see what the reveal says. The rectangular prism boxes should be used because they will cost the company $2.50 less than using the cylindrical containers, which is exactly what we just said. Orchid wants to retile her bathroom floor, which has an area of 40 square feet. She's deciding between two types of tiles. The square tile is 1/2 foot by 1/2 foot and costs 45 cents per tile. The rectangular tile is 2 feet by 1/4 foot and costs 80 cents per tile. Okay, so obviously she wants to spend the least amount of money, seems to be the concern here. So let's calculate out each situation. So let's see. I'm going to just split my work area right here and see what I can do with it. So on the left side over here, let's do the square. What are we dealing with? The square tile. Okay, so what do we know about the square tile? The square tile is 1/2 foot by 1/2 foot. Okay, so if the square tile is 1/2 by 1/2, okay, 1/2 times 1/2 is 1/4. So each tile equals 1/4 of a square foot. Okay, that's how much it covers. It's 1/4 of a square foot. What else do we need to know? Oh yeah, the cost. The cost of this thing, I'll just put it off to the side here. The cost is 45 cents. 45 cents each. So now let's use that information to calculate the cost of the project. Well, let's see. We need to cover 40 square feet. So if we want to find out how many tiles it's going to take, we need to figure out how many times 1/4 of a square foot goes into 40 square feet. Okay, so if we want to cover 40 square feet, we need to do 40 divided by 1/4. That will tell us how many tiles. In fact, maybe I should write that down. Sort of like I did with the cans, the box and the cylinder on the previous problem. So we're answering the question, how many tiles? How many tiles? Well, we'll take the total area that we need divided by the area of one tile, which is 1/4. All right, that should tell us how many tiles we need. So if I do 40 divided by 1/4, all right, that's 160. So I would need 160 of these tiles. Okay, so how much would that cost? Well, 160 tiles times 45 cents each will give me the cost of this. So 160 tiles times 45 cents, that's $72. Okay, so that's how much it would cost for this project if I did it with square tiles. Now let's do the math again. using the rectangles. Okay, so the rectangle tile, those dimensions are, let's see, 2 feet by 1/4 foot. Okay, so the dimensions, I'm just going to put it up here in this space. All right, these are the dimensions, 2 feet by 1/4 foot. All right, so that means each tile covers, all right, length times width, 2 times 1/4, okay, is going to be 1/2. No. Yes. Let's see, 2, let me clear the screen. All right, 2 times 1/4. Okay, that's 1/2. So each tile is going to cover 1/2 square foot. Okay. Oh yeah, and let us not forget the cost, which is 80 cents per tile. Okay, so that's all the information that we need. So again, let's figure out how many tiles and how much that will cost. So how many tiles will we need? Well, we need to cover 40 square feet. Each single tile covers 1/2 square foot. So if I want to figure out how many tiles, I'm going to have to do the total area divided by the area of each tile. So 40 divided by 1/2, that should tell me how many tiles. So that's going to be 80. Okay, so I'm going to need 80 tiles. Now let's figure out how much that's going to cost. Alright, well 80 tiles, so that means I need to do 80 times 80 cents. That's $64. Okay, so clearly we should go with the rectangular tiles. Let's see, 72 minus 64, just in case they ask how much we're going to save. Whoops, that was supposed to be subtraction. 72 minus 64, that's 8. Alright, so it's going to be $8 cheaper if we go with the rectangular tile. So we should go with the rectangular tile. Let's do the big reveal. She should choose the rectangular tile because the total cost will be $8 less. Just like we said. That was number 13. Alright, here we go for the last problem. A city's bus line is used more as the urban population density increases. Alright, so high density equals bus used. Okay, the more people in an area, the more likely bus lines will be utilized. Well, yeah, we just said that. Population of city A in Texas is 29,455 and covers an area of 19.42 square miles. Okay, so keep in mind that population density is the population divided by the area covered. Density equals population divided by area. Okay, so let's calculate the density for each one of these cities. Okay, so if I want to do the population density of city A, okay, so here comes city A. For city A, the population density is going to be the 29,455 divided by the 19.42. Okay, so that's 1,517. I'm rounding up. Okay, now let's do the same thing for city B. Okay, so that's going to be population of 34,890 divided by an area of 25.4 square miles. Let's see what that gives. Okay, that's 1,374. Again, I'm rounding up. 1,374. Okay, which city's residents are more likely to use the public buses? Well, higher density means more likely to use those buses. So whoever has the higher density, and we can see that city A has the higher density. Okay, so it's definitely going to be city A because they have the higher density. I'm just going to go ahead and subtract these two numbers. Just sometimes they ask something about how much more or something. So just in case, I will do 1,517 minus 1,374. Okay, it's 143 more. Okay, let's do the reveal, the final reveal. Alright, the residents of City A are more likely to use the public transportation because the city has the highest population density. Okay, just as we suspected. Alright guys, I hope this video was helpful to you. Good luck on your quizzes and such.